one thing, which is this. I squared equals -1. That's all you gotta know. And if you know that, I can teach you imaginary numbers. That's all you gotta know. Okay, now watch. I'll show you how easy this is. Okay, look at this problem right here. You've been solving problems like this. Okay, 2x squared plus 11 equals -37. You gotta solve for x. What's the first thing you gotta do? Subtract 11 from both sides. Subtract 11 from both sides. This is what you've been doing this week. Okay, you get 2x squared equals -48. What's the next thing you're going to have to do? Divide both sides by 2. Perfect, you got it. Divide both sides by 2. Okay, you get, okay, x squared, okay, x squared equals -24. What's the next thing you're going to have to do? Square root both sides. You got it. Square root both sides, like this, okay? You get x equals square root of -24. Okay. Okay. If it's not a real number, if it's imaginary, here's what you do. Now watch. It's going to be real detailed for the first one. -24 equals this, guys. It equals -1 times 24. -1 times 24 is -24. Oh, but wait. What does -1 equal? What does -1 equal? I squared. -1 equals I squared. Look at there. So you know what you're going to do? You're going to take that -1 and change it into I squared. Change it into I squared. Exactly right. It's going to become I squared. So now, instead, you're going to write this. Square root of 24 I squared. It'll become 24 I squared. Like that. All you're doing is taking the -1 and changing it into I squared. So it becomes square root of 24 I squared. Okay? All right, now let's do this. Oh my gosh, I've done this before. I can do this, right? Okay, what's 24 equal to? 2 times 12. What's 12? 2 times 6. What's 6? 2 times 3. So you're going to have 2 times 2 times 2 times 3 times I times I. I times I is I squared. What you're going to get? 2 times 2 times 2 times 3 times I times I. There you go. Now what do? You circle your pairs. I've got a pair of 2's and a pair of I's. Pair of 2's, pairs of I's, right? What am I going to take out of the square root? 1, 2, and 1 I. 1, 2, and 1 I. You're right. I'm going to take out 1, 2. Okay, come here. 1, 2, and 1 I. You got it. What's still going to be inside the square root? 2 times 3, 6. Square root of 6. There you go. Everybody okay now? Any questions? Everybody's okay? Everybody's okay, right? Everybody understands? Everybody's okay, right? Okay, right? Got the answer? Okay. Everything good? Everything's good, right? Right? Everybody's good? Everybody's okay? Got the answer. What are you forgetting? Plus or minus. You forgot. Quadratic. Plus or minus. Now you're okay. That's the answer. Okay, plus or minus 2I square root 6. There's your answer. You got it. Now you're okay. That's how you do the first one. Anybody else so far? Look, here's what we're going to do. Let's take this problem right here, or the one you just finished doing. Okay, here it is right here. Okay, but do this now. Let's add the 37 back over here, okay? So you get what? 2x squared plus 48, right, plus 48 equals 0. Now let's do this. Let's take away the 0 and put in its place a y. Put in its place a y. You did this earlier with other things. Okay, let's make it into a y. Okay, do this for me. Go and graph that on your graphing calculator. Y equals 2x squared plus 48. And you might have to make the X max, I'm sorry, about the Y max a bigger number, like 100, make it to 100. So it comes out to be a good graph. Okay, let's see if you're getting what I'm getting when you do that. You get something that looks like that? Everybody getting that? Okay, now look at this for a second. Wait, hold on, wait. Wait, earlier when you told me this, that parabola hit the x-axis. That's right, it did. And where it hit the x-axis, that was a 0 or a root, remember? And I would find out, wait, the answers are right there and right there. That's the roots, the zeros, right? You're right. But it's not hitting the x-axis. You're right, it's not. Wait, that's telling me something. That's telling me since it doesn't hit the x-axis, like this one does. Here, that and that were real roots. Oh my gosh, I get it now. It doesn't hit the x-axis. Therefore, it's not going to be real roots. It's telling me I'm going to be imaginary roots, imaginary solutions. That's a trick, okay? So whenever you graph these things, if it never touches the x-axis, it's telling you, I'm not a real answer, I'm an imaginary answer. It's telling you something. That's what you're finding out about. We'll learn more about that in another lesson. Okay? All right, let's go to this one now. Here's example 2. Okay? I got to get 5, so I got to get x plus 5 squared by itself, right? What's the first thing you're going to do? Add 8 to both sides. You got it. That's what you learned. Add 8 to both sides. There we go. So you get this. Negative 35 plus 8 is negative 27. Hey, Lobster, what's up, girl? How's it going, huh? How you doing? Everything okay? Okay, good. What's up? Just hanging? Just hanging? This one. Okay, so here's what's up there now. Okay, we got to get x plus 5 squared by itself, all right? So now what do you have to do? You have to multiply both sides by 3. Okay, so we're multiplying by 3. There we go. So we're multiplying by 3 here and by 3 here, right? Okay, so here's what we get. We get what? X plus 5 squared, right? X plus 5 squared. Okay, and that equals what? Negative 81. Okay, now what do you got to do? Square root both sides, right? You know it. Square root both sides like this, right? Okay, now you're going to get x plus 5, right? X plus 5, right? Like this. Okay, now I'll bet you can do this in your head. What's the square root of negative 81? 9, yeah, plus or minus 9 I. 9I is what you'll get. That's right. Now, if you're confused, here, I'll do this over here for you. Look, here's why it's not 9, okay? Look, here's this, okay? That negative, you take the negative away and put in place I squared. So you get 81I squared. What's the square root of 81? 9. What's the square root of I squared? I. So you get 9 in I. Plus or minus 9I. It's that simple. That's what you get. Plus or minus 9I. Oops. Very good. Come on, 9I. There you are. Right there. Okay? All right, now here's what's up next. Now what are you going to do? You're going to subtract 5. So you're going to get your answer. X equals what? Negative 5 plus or minus 9I. You got it. You see how easy it is? Negative 5 plus or minus 9I. There's your answer right there. Okay, there you go. That's it. Okay, everybody good? Okay, let's go to the next page. All right, now here comes the next part. There's a world that exists that's nothing but real numbers, like 1 and 2 and 4 and negative 3. They're all happy, love each other. Man, oh man, great. We're in a real world of numbers, right? Guess what? There's another world. The world of imaginary numbers. 2i, okay? Negative 3i, okay? Negative 7i, 4i. The world of real numbers, right? Both of these numbers just go around and do their own thing. Oh, this is great, until one day, oh my gosh, look what's about to happen, look out. Guess what happens? They collide. They collide. They run into each other. they become one world. Okay? They become one world. All the reals and all the imaginaries have to live together. One day, you know what? There's one looks over there and says, ooh, wow, look at that negative 3 eyes. Yeah, I like her. And negative 3 eyes says, oh man, I like that one. And they get together. Suddenly we got 1 minus 3 eyes. They decide to become 1. Hey, and look at this. Here's 4. 4 decides to get together with 2i. It becomes 4 plus 2i. And look, here's 2. 2 gets together with negative 7i. It becomes 2 minus 7i. And here's negative 3. Okay, it gets together with 4i. It becomes negative 3 plus 4i. Okay, here's the thing now. You have a new kind of number, a complex number. Or sometimes I call it a complex imaginary number. It's a real number and an imaginary number living together, right? Together with each other. Okay? So you now know about 3 different kinds of numbers. One is a real number. One is a pure, oopsie, sorry, it got popped up there, sorry about that. One is a pure imaginary number. And one is a complex imaginary number. Okay, 3 different kinds of numbers. Okay, and here's what we're talking about. We're talking about these complex imaginary numbers, or complex numbers. Okay, look how easy this is. E minus I plus 5 plus 4i. Look how easy this is. How much is 8 plus 5? 13. 8 plus 5 is 13. Look at it, 13. Okay. How much is negative I plus 4i? 3i. The answer is going to be what? 13 plus 3i. Look how easy that is to do. Okay. There it is. 13 plus 3i. Okay, look at the next one. How much is 7 minus 3? 4. Okay. 7 minus 3. Okay, oops, there we go. 4. Okay, how much is negative 6i minus negative 6i? It's going to be 0, right? It's going to be negative 6i plus 6i. It's 0. The answer is just 4. How about this one? Here's 10. What are you going to do with that negative? Distribute it, right? You're going to distribute it like this. 10, okay. Oops, hold on. We're going to get through this. Okay, here we go. 10, okay. Okay, minus 6, minus 7i. Okay. Then what are you going to do? Add 4 more I to that. Okay. Combine like terms. What are you going to get for the answer? 4 negative 3i. You're right. 4 minus 3i will be the answer. Here it goes. 4 minus 3i. Look how easy that is. Okay. Let's look at the next step. Now you're multiplying. What's 4i times negative 6? Negative 24i. Right. You get 24i. There you go. Okay. Now, what's 4i times I? 4i squared. Okay. 4i squared. You got it. But look at this. I squared is how much? Negative 1. So now it's going to become 4 times negative 1. 4 times negative 1. What's 4 times negative 1? Negative 4. Right. It's going to become this. Okay. Negative 24i minus 4. Oh, but wait. How do you write this? Always the real is first, the imaginary second. So it's going to be what? Negative 4 minus 24i. That's how you write this. Negative 4 minus 24i. Okay, everybody good so far? That's the reminder. I didn't do this through. Okay? Everybody good there? We're done. Hey, look. Thanks, Larry.
Still good to go?
I'm good to go.
All right.
Grab some real quick drink here. We'll take it.
Thank you.
You mentioned that, Bob.